I'm sorry I have to speak in English. I wish I could speak your language, but that's much better. We have a bit of a trade-off going on here. I want you to see the slides, but we're also trying to live stream. So we're going to shut down the lights so you can actually see the slides. It's our standard confidentiality disclaimer agreement. But I'm going to be talking about what we call connected intelligence. You're connecting to data and you're getting intelligence from it. And so I'm going to give a couple of case studies and then talk about data science in operations, how you get insights from data and how you put them into operations. So we're going to start off with a case study from Siemens Rail on predictive and condition-based maintenance. And really the idea of connected intelligence is to unlock the potential of real-time data for making faster and smarter decisions. So you connect to data in real time, you unify data as it accumulates, and then you predict from those data. That's the three pillars of our connected intelligence portfolio. So if you think about Siemens Mobility, they have built this thing called the Railagent data analytics platform on top of TIBCO technology. And this is the German here, but it translates to operation and maintenance are optimized. So this is a fairly significant operation. They have solutions for urban, interurban, freight transportation, rolling stock, intermodal solutions, intelligent traffic systems. They run trains and they also sell their trains to other people. The first meeting I have when I go back to the United States is with a company called Norfolk Southern, and they run the Eastern Seaboard train operation in the US. And they have a very similar portfolio set up, on TIBCO technology. So this Siemens Mobility, 9 billion revenue, 34,000 employees. And what they've done is, powered by connected intelligence, they're basically understanding predictive maintenance. They're getting schedules for when to maintain the equipment based on a reliability analysis, survival analysis, time in service of the individual parts of the train. But then they're also looking at the train as it's going down the track, and they're doing real-time condition-based maintenance to basically figure out a degradation pattern and immediately alarm the train operator so that we can deal with it in real time. So this is the plan on the left, and this is how we respond in real time there on the right. And this Railagent platform, includes obviously predictive maintenance, condition-based maintenance, but also capacity planning, management, route planning, optimization, forecasting, resource allocation. And really they have a lot of data. These rail vehicles send between 1 and 4 billion data points per year per vehicle. The infrastructure and signaling can send billions of messages throughout the year, throughout the day. And the measurement of the infrastructure in one round trip, you get about a terabyte of data that is accumulated. So you're able to, based on those data, as they accumulate, you're able to figure out maintenance schedules. You're able to run the train with real-time data and improve, the experience of the customer. So two sides of the coin. I want to talk about maintenance. Firstly, predictive maintenance is based on, let's see if I got a little pointer here. I don't have a pointer to it. So the idea with predictive maintenance is you look at time in service on the x-axis, you look at cost on the y-axis, and you look at the cumulative probability of failure versus time. And if you multiply that by the cost of an unplanned downtime, that gives you this red curve. So the red curve is the cumulative cost as a function of time in service of a piece of equipment. When you don't maintain it, you have a risk of incurring a high cost. Now, if you maintain too often, well, that's the green curve, because then the cost of maintenance is too high. So you can't maintain too often, you get it's too costly, but you can't let it go too long or you'll have a catastrophic event. So somewhere in the middle there is the optimal point. And I think this is a video. Let me run the video. So here you can see that trade-off, and we want to get to that blue curve in the middle that trades off the cost. And so in the analysis that I'll show you we have on the website, you can put in the cost of a planned maintenance event, the cost of an unplanned failure. You can recalculate the event here. And this analysis is all based on this fraction failing versus time in service, that curve there. This is actually a two-parameter exponential or Weibull distribution. You can see the log scale of on the x-axis there, and we can fit a straight line to that. And then you construct from that this cumulative probability of failure or the cumulative distribution function that is the underpinnings of the calculations for the maintenance schedule. So that's what we call predictive maintenance, or PDM for short. Now, condition-based maintenance is quite different. Condition-based maintenance is when you have data coming off the equipment in real time and you want to monitor the equipment as it's sending out data. Now, this example is, we do a lot of work in the energy sector. We manage drilling and production operations for most of the energy sector worldwide. This is based on a customer, Occidental Petroleum in Houston. And they have about 40,000 wells that they run through our technology. And each one of those wells has some kind of data coming off of it that gives you a hint as to whether there's going to be an issue, with the equipment. So we're monitoring here pressure in this column and current here in this column. And if the pressure goes up too much, that can mean a problem, a blockage somewhere in a tube or gas buildup in the downhole. And if the current drops, the current draw drops, well, that's also a problem. If these two things happen together, that's a big issue. So we have set up these little sliders up here, the pressure and for the current. We can move those around to figure out when to make an alert to somebody. And let me run the video. This should be a video. Let's see. On a video. Was it video? Maybe it's already.
It's there.
Maybe it's on this. Did I see the button? Oh, there. Okay, so you'll see here that these pressure and current values are changing. Each one of those little diagrams over there is an individual well that's represented here on the map. And you can see if I move that slider for the pressure, if I move that down a little bit, things are going to start, turning red. I'm not sure I'm moving that down. But the idea is each one of those dots there is a well. This is the current for each of the individual wells. That's the pressure. And you can see that we've figured out how to color in red when that goes too low or that goes too high. And then we reflect, that coloring on the map. I might run that again just to watch it. Yeah, so you can see things changing as the real-time data, come through. And you can see that, yes, you can see when I slide it up, I get more green. Slide it down, I get more red. And based on this, Occidental Petroleum has this online portal called OxyLift, where the exceptions, the alerts, get put out into a real-time table, and the engineers in the field can go and look and see if their well has a problem, and they can go and maintain it. So that's condition-based maintenance on the other side of the coin there. Now, we have a ton of these types of applications for predictive maintenance. And, I'm also going to talk about dynamic pricing, pattern recognition on wafer maps. We have really a lot of work being done on anomaly detection, fraud and risk management, which Anna here in the audience worked on some years ago. We've evolved that. I'll look forward to catching you up about that. Customer engagement. So all of these applications, we call them AI apps. And you can go to this website here and you can see them. And that's all real-time data, and it's data science inside. I'll run this little video here. This is one of our anomaly detection applications. And you can see how once you've found some anomalies, how you can cluster those into patterns so that then when you get a new anomaly, you can say, oh, that's like this one. And I've got a plan for fixing that. So there's a lot of work that we've done on anomaly detection to find the anomaly and then figure out what's the root cause for the anomaly. But if you go at your leisure to this website, you'll see a number of the demonstrations, and I think there's the predictive maintenance one there. In fact, maybe I can jump out there and give you a little tour. And I think I have 20 minutes for the talk. Is that right?
Yeah, 30.
Oh, 30. Good. Okay. All right, great. So I can spend a little time here. So this is the website that I mentioned, and you can go in and take a look at whichever one you want to look at. Let's see. I thought that this demo was running a little bit short. I want to play with it a little bit more. So let me open it. So this is all running inside a Spotfire cloud, and the data science and real-time analytics is inside of that. So the equipment alerts here. I can see the wells. Let me go to these adjustable alerts. I think this was the screen that I was showing in the video. So let me show this a little bit more detail. If I drop the pressure, alert, say, down a little bit, then everything's going to turn red, right? If I raise it up a little bit, there's going to be a mixture of red and green. And you can see how we're keeping track of the real-time data as it arrives for each of the wells. We're keeping track of what's going on, this is in Texas, and we're keeping track of the data, and we're also keeping track of the alerts. So I will leave you this as at your leisure to go and look at other types of data science, real-time applications that we build at TIBCO. And we're all about smart, immersive, and real-time. We want everything to be data science driven. We want it to give you the immersive experience of creating your own applications. We want it all to respond in real time. Okay, so let me jump back in here. And look, we can have this interactive. If anyone has a question on anything, just interrupt me. Okay, so what's under the hood of those applications? We all want to build, smart, immersive, real-time applications. That's how you generate value on a business. So what's under the hood of this is the connected intelligence portfolio. And so we integrate data in real time. We analyze data on the event stream, this top row, and we visualize those results. You've just seen that in action. But we're also accumulating data into databases, data structures. The hot new word for that is the distributed data mesh. And then from those accumulated data, we do data science and we push that into visual analytics. And so if you think about, and then we put APIs on things and we do master data management. And overall, this is the connected intelligence portfolio of products. And we, apply that to whatever data. Snowflake's a big trending data. It seems like every customer I talk to is trying to make some investment in Snowflake these days. But, the data storage, the cheap cloud data storage, we connect to that. The various products from, say, Amazon Redshift, AWS, or Azure Synapse. A lot of data out there at the moment that we're connecting to. And so this is a generic view of what a Lambda or Kappa style architecture is. And everybody wants to be able to do this type of thing, do data science on accumulated data, put it on the event stream, make a decision in real time. And it just so happens that we have a product in every one of those categories. So what I've shown you so far is TIBCO Spotfire for visual analytics. We've been putting data science models onto TIBCO Streaming. We manage those models in TIBCO ModelOps. We integrate data through TIBCO Messaging and Integration. EBX is our master data management product. Mashery is our API product. So all those applications that you have the demonstrations for, you can build those pretty simply with TIBCO technology. Okay, so I'm going to go through one more example. If someone can give me a 5-minute warning, would that be okay? This is going through a second example around dynamic pricing. I always try to do one example on sort of engineering and one more on finance or customers. And so we're going to walk through the data science lifecycle of connecting to data, engineering features, doing modeling, deploying the model, monitoring, rebasing the model, what we call continuous analytics. So this is the data science lifecycle. Define your project, start acquiring data, do some initial exploration, engineer some features, build some models, refine the models, deploy the models, monitor the models, refresh them. That's really the data science lifecycle. And in terms of the data science pieces that's relevant to this audience, we have a product, TIBCO Data Science, that allows you to point and click your way through a pipeline. You can also drag a Python notebook onto that canvas. As you analyze the data are kept in the source system. They're run through delegated compute at scale. And then the result set is written out through TIBCO Data Virtualization. This is our data management layer. And TIBCO Data Virtualization, we read from that in TIBCO Data Science and we write back out to it. And Spotfire, our visual analytics software, easily connects to data virtualization. You can search the view that you've just created. You can do interactive visualization. So essentially, you can have one person sitting in Spotfire and another person sitting in data science, and that's all interoperable. So one of the customers that I'm most proud of, that I haven't included slides on today, but is Pfizer. So Pfizer has now standardized their global manufacturing operations on this technology. They've got 42 worldwide manufacturing locations. They do the data science to monitor the yield of the product, as well as monitoring the equipment, much like the pumps that I showed you for the energy sector. And the equipment, one of the big use cases is the freezer farm. They have to keep the temperature of the product at minus 38 degrees. And so we have, they're very good at this, what they call soft sensors. And so we read in that soft sensor data in real time, and we monitor that equipment to make sure it doesn't go outside of that range around minus 38 degrees. But what's happening at Pfizer, and like what's happening here, is the analysis runs against the data that's accumulating. It's written out through TEV. It's looked at in Spotfire. It's also, as the real-time data come through, the model is put on to the event stream, and the model is scored in real time in Spotfire. We could have another slide up here for TIBCO streaming, but I think about TIBCO streaming as really a data source for TIBCO Spotfire. That's really the strength of it. But these are the foundational elements. And then from our TIBCO data science offering, we publish the model to TIBCO Model Ops. That's a pretty new product for us. We just launched it. Version 1.2 is coming out next month. And this allows you to map the inputs of the model to the new data. So mapping the model parameters to the new data is the first little box there. You can optionally do some data prep. And then the model, you wire it up to listen to new data coming in on the event stream, and then score the data science model with the new data, and then you output the score. Now, it has a concept of sources and sinks. So the source could be a Kafka stream, and you might write the results out to a Kafka stream as well. In that case, you'd have a source and sink that was Kafka, or you could go in with Kafka, out with a database, that sort of thing. So it's a very flexible approach to deploying a data science model. So when you put all that together, the visual analytics, data science, and streaming pieces in the Predict portfolio, we call that hyperconverged analytics. And a number of our customers are using those three products together in that way. Okay, so we've peeled back the onion a little bit from the Siemens example into data science, visual analytics, data management, a little bit on data management. But let's expand the data management part, because that's where a lot of attention is. What they say that data scientists spend 80% of their time cleaning data and 20% of their time complaining about cleaning data. Isn't that how it goes for data scientists? So yeah, it's a lot of data management and data cleaning are involved. And so we have a lot of products in that area for unifying your data. So getting, for example, let's use this. No, I can't use that. So combining your data, cleaning it, preparing the data for analysis, managing the views on the data, putting governance around that, and the governance can be at the column level, the row level, the object level, and then provisioning that up, to the business. So this one of the hot topics last year was around this data fabric, this agile data fabric of going from your data sources to acquisition, refinement, master data management, data access, governance, security out to the business, across data platforms. And this is often the remit of the chief data officer. Now, the hot trend right now, though, is the distributed data mesh. And this is taking a layer on top of the agile data fabric and providing some domain-driven ownership, lines of business, where you provide data as a product. You've already created the federated views on the multiple source systems. You provide that up to the business, where you can discover the views. The views can be multi-data source federated views. You can understand the metadata of that. And then the IT organization pushes those views out to the business to fuel data domains and use cases. So that enables you to more quickly do the sort of things that I was talking about, the applications I was talking about. So this big trend, this distributed data mesh that Accenture's out there pushing, and ThoughtWorks, these are some of the big companies who are pushing this trend. We see it as a really great thing for us, because really all of those pieces are covered with TIBCO Data Virtualization and TIBCO EBX, our master data management product. So we're pretty excited about that. And I wanted to just give you a brief view of what those products do. TIBCO data virtualization is a virtual layer with semantic consistency. So just think about all of your data assets and you just have one interface and you can write SQL against it, and the data from multiple source systems are available to you to do analytics on. So combining diverse data sources, whether they're on premises or in the cloud, with self-service business access, governance at the column or row level or the object level, and then providing that 360 view of everything that you need. In the banking industry, oftentimes there's silos of data for lending and online banking and wealth management, and you want to get a single view of the customer. You don't want to have to go in all those different departments. You want to know for a certain customer, what are they doing when it comes to saving and lending and online banking and so on. So that 360 view is a pretty foundational element of this, and providing data as a service, as a product, and bridging, at-rest data and real-time data is often a key thing to do, because your databases are accumulating at different time frequencies. Some data might not change but once a month. Some data is changing every minute. How do you get the latest view across all of the data sources to provide that real-time view of a 360 view of your customer, for example? So that, represented here, I live in San Francisco. I'll use the bridge, our local bridge there, to sort of give you the image of data being in a warehouse that's not changing very fast, and data that's moving very quickly. How do you combine those together to give yourself a view across multiple systems to do data science and analytics? And so that's part of what we do with the data science product, is we connect through TIBCO data virtualization to all those different data sources to do the feature engineering and data prep. We connect out through Spark to run the machine learning jobs. And that gives us a world of data that we can build our models on and deploy that. So that's data virtualization. It really is a unifying concept across many different source systems. Now, master data management, we have a wonderful product, EBX. We acquired a European company a couple of years back, Orchestra Networks, and this has become a big part of our portfolio. So this is a model-driven way of managing your data with any domain of data. We have, once you model and manage your data, you can put different hierarchies on it. You can have an engineering hierarchy for managing the assets. You can have a financial hierarchy. Different hierarchies are very powerful concepts. It's designed for business teams. It's got a pretty easy user interface. And, this data modeling to capture the object attributes and relationships between the different data elements that you're interested in, data quality with rules, match and merge type rules, managing the life cycle of the data. And the life cycle can include different people getting approval to publish different, say, wells or customers to the model, managing the hierarchies I mentioned, stewardship, workflow and security, and in integration. This is a very powerful product. Okay, so I've given you a bit of a view of the portfolio. I've got one more case study. Do I have time for the last case study?
You have say 7 minutes.
7 minutes. Okay, so we're going to do one more case study around dynamic pricing. And this is a hot topic in the insurance industry, because there's companies like Lemonade that just have disrupted the insurance industry by providing self-service insurance for your car, your house, your dog, whatever. And the traditional companies are trying to keep up. So if you think about that online self-service insurance, what happens when someone puts their information into a website is we add them to a segment. The segment has a sort of base discount. We do a little randomization on that so we can do a post hoc elasticity analysis, and then we put out the quote. So that's the online system. But behind the scenes, we are fitting a machine learning model to look at the policy renewed, yes or no. Did somebody renew their policy based on the data they put into the website? And how do the customer attributes predict the probability of an offer for a premium being renewed? And that's where you go into the segment, the micro segment. You figure out the price tables. You want to give discounts based on how long a customer's been with you. What's their claim history in previous years? You've got retention rates for different segments. Obviously, if someone's been with you a long time, they pay their premiums on time, and they've never filed a claim, that's a pretty good customer. So you want to give them a pretty good discount. So that's all built in. So the way we do this is the data virtualization is our data source that I mentioned. Policy renewed is a response variable we want to optimize. This is very big data. So oftentimes we'll start out with a TIBCO data science sample of that data that's fed into Spotfire. In this case, the gray bars are when the policy is not renewed. The blue bars is when it was renewed. And so you can now start to explore. That's what Spotfire is great at, is exploratory data analysis. And you can say, what are the variables that are related to whether the policy gets renewed or not? What the type of car, a hatchback or SUV. How looks like the SUVs have a lower renewal rate, as do convertibles, and hatchbacks have a very high renewal rate. Continuous variables here, like the vehicle value, clearly has a big effect on whether there's going to be a renewal of the policy. So we do that exploratory analysis. We understand what predictors might be related to the target variable. We look at the relationships between the X variables, understand where there might be correlation between the X variables. And then we go back and we fit the data on the fit the model on the full data. Our data science product is very scalable. So we'll just go consume hundreds of millions of rows and fit the full model. And then we'll summarize the model and publish it out to TIBCO ModelOps. And that's where we start to wire up the model so that we can, score that on the event stream. So this is where you map the data channels to the parameters of the model. You score the data. The derived data is the decision tables and the discounts and so on. And then you output that to the event stream. So let me run just a video. Yeah, this is a video. So this is a video of I've got the dynamic pricing model now into ModelOps. I'm wiring up the inputs, the new data inputs to the parameters of the model. See, I pick my data channels there. I'm wiring that up. And now I'm listening to the new data on the event stream, where I'm going to predict the probability of renewal. And then I'm going to look at on the real-time data where renewals are happening, which part of the country they're happening in, distribution of renewals by age, the premiums that are being renewed or accepted over time. And then what is the profitability of this campaign? Oftentimes you'll do a campaign for a new product, a new insurance product. So what's the total commission, total business value, the cost to win the business, things like that. You can monitor all of that on the event stream. We've also been doing a lot of work now on drift, model drift, and understanding, once you've got a model in production, how do you monitor it to make sure it doesn't need to be retrained, or finding out when it does need to be retrained. So that, historical data is coming in, you're modeling it, you're deploying that on real-time data. And after that model starts to drift, you might need to rebase that. So that's an area of active work for us. And I think that's my last case study. I did have a few comments about Mercedes, the work we do there, but I think we're probably out of time, right?
You can go for it.
You know, a little bit more on Mercedes?
Go for it.
Okay. So it's difficult for me to give a talk without mentioning the work. I know Anna used to work in our team. We have a lot of people working with Mercedes, and I know Formula One's very popular in Europe. So I did have a few slides in here. We have won 8 championships in a row. We've been with the team a bit over 5 years, so we've had a good contribution to this. It's a very fast sport, and so it suits us. We're like real-time data guys, right? I was fortunate enough to be standing above, this is at Monaco, and watching the cars come into the pit stop. At that point, it was about 1.8 seconds to change the tires. It was really fast sport. There's some regulations have been added to that to change that a little bit recently. But with that, we generate a lot of data. I like to show this slide when my CEO's in the room, why I should get paid more than Lewis Hamilton. But it is a fact that the sport has become very mathematical and very data and analytics driven. And so the stuff that we do for them, this is the new W13 car. I know we've got a little bit of trouble with it at the moment. It's kind of bouncing a little bit, and it's hard to get the ride height, down close to the track like we had it last year. But, the huge regulation change last year. So we're just trying to figure out, how to deal with that. And I was talking to them yesterday, and it's 3 years we're going to have this new regulation. 3 years we're going to have this car, and so we're trying to find a long-term fix to this bouncing problem, not just a short-term hack. But it is a good car, but unfortunately Ferrari and Red Bull have got good cars too. But what my data science team does, we do a lot of simulations. So before we ever go to the track, there's about 50 setup parameters on the car that you can configure at the track. And so we do simulations. We've got digital twin models for the car, and we do simulations varying all of those 50 parameters. Now, if you chose 3 values on each of those, 3 to the 50 is a pretty big number. So we literally do billions of simulations. And then we save all those simulations into a Spotfire analysis, and the engineers take Spotfire to the track, and they're constantly adjusting those 50 parameters. So you get to the track on Friday, you do your first practice lap, and then the driver comes in, you talk to them, and you start changing the setup of those 50 parameters based on how you can get more adaptability to that particular track. So that's a huge part of the work, is the digital twin simulations. We also, with the car design, we do a lot with the aerodynamics, with the wind tunnel testing, configuring the gearbox and so on. And then during the race, we have some models around things like overtakes. What's the best time to do an overtake, and what car, position on the track, the tires that we have versus the car in front of us. A lot of factors go into that. We're doing a lot of anomaly detection and root cause analysis. So it's been fun. There's a quick picture there of that's the 60% replica of the car, 60% size, smaller than the real size. That's the car in the wind tunnel, and the wind tunnel pushes wind against the front of the car, which simulates the car driving into the wind on the track. And the engineers have a certain idea about how to optimize the aerodynamic properties. We put that into the scaled model. We run the simulations in the wind tunnel, and we figure out, is that a good idea or not? Now, we've done some really interesting data science there where we've figured out, if it's not going to be, it's not looking like it's a good idea, we can stop it and save that time, because each team gets a short amount of time in the wind tunnel. It's a fixed amount of time you get in the wind tunnel. And in fact, last year, because we won the last 8 years, they penalized us even further. So we get about half the time in the wind tunnels the other cars. And so we have to be really efficient about how we use that time. But yeah, a lot of work goes on in the car design. Digital twins I talked about. This is Mike Sansoni, who runs the VDG group at Mercedes, and talking about how these billions of combinations that they test the 50 setup parameters against on the race weekend. Now, when you get to the race weekend, literally our software is all over the engineering group as they're trying to figure out what's going on with the car. I'm excited. Next weekend, I get to go to Miami. It's the first race that we've ever had in Miami. So it's the second track now in the US that has a race. And then the week after that, they're pretty close by here, right? They're over in Barcelona. That's a pretty cool track. I've been to that one. The way these things work is that there's these DRS zones. And so when you get into that DRS detection zone, if you're less than a second to the car in front of you, you get to open the flap on your rear wing, which gives you better aerodynamic properties and speeds you up, because they're trying to encourage overtakes. And so that is there's 2 DRS zones in Barcelona, and there's this long straightaway here where a lot of the overtakes end up happening down here. So if you go to Barcelona track, this is always a good place to sit. And at the end of this straightaway, you can see the overtakes. And as I mentioned, we do have some models for overtakes based on the gap to the car in front, the latent speed differential, the tire type, age, the outlet frequency. Here's that what I just mentioned. When during a second to the car ahead, you can open the back wing, and that reduces the drag and boost the speed. Now, regulations, we obviously had a big change this past year, but the year before, we had a cost cap was introduced. For example, how we get less time in the wind tunnel. But each of the teams has now got a $175 million cost cap, which is about the same as an NFL team in the US, about the same cost cap. And prior to this, Mercedes and Red Bull were spending whatever they wanted, and there's other teams were at a disadvantage because they didn't have that much money. So we're now putting the cost cap in, and we've been working closely with them on these visualizations, these visual analytics, for looking at cost benefit. Now, Spotfire version 11 has this ability to extend the graphics palette. And one of the guys on our team created this icicle plot where each of these units here is a sub-assembly of the car. And so if you click down into one of those, you can see all of the components in there. You can see the cost of each of them and, their performance gain. And it gives you an idea of how to, reduce the cost while optimizing the performance. And one of the great things about this is it's the finance group, Mercedes, F1, and the engineering group really weren't talking very much at all. And now they are because of this regulation. And they're all coming into this one analysis and they're seeing, okay, what are these engineers spending the money on? So this is the quote from the CFO who has now got, he's got his tentacles out there into all the engineering groups and making sure they don't, spend willy-nilly. Okay, so that's it for the Mercedes example. I wanted to just mention the Analytics Forum. It's an annual event. This year it's free. It's virtual. It's June 13th to 15th. It's European time zone friendly. And so I hope you can come. Our keynote, Nadi Bremer, is just an amazing visualization expert. She's often featured in Scientific American. She's going to be kicking off this visual analytics. She's a JavaScript developer as well. And our Spotfire mods is all based on JavaScript. So she's an obvious keynote to get. But yeah, she's pretty amazing. Got 42,000 followers on Twitter. She also works out there all over the place. That's day one. And day two, we've got Ben Schneiderman talking about human-centered AI. How to get human control and increase the level of automation. He's got a new book that just came out, so he's going to be the keynote on day two. And I'll just close the presentation today with a little video of us doing real-time analytics on an F1 simulation car here. And we often do these when we have live events. You can come and sit in the car and drive it around the track, and we're getting real-time data. And we're putting that into a Spotfire analysis. We're predicting your lap time. We usually keep a leaderboard of folks who have the shortest, lowest lap times, and they get prizes. But this is part of the work that we've been doing with the team. We're also building into our marketing and trade show events via this type of thing. Okay, so I'll wrap it up. I've shown you our data mesh, data science, and visual analytics, how they operate together. I've shown you the continuous analytics with streaming. And that really is our connected intelligence portfolio. And I thank you for letting me be part of this event today.
Michael.
Hey there, all you visual analytics enthusiasts. I'm super excited about the 2022 TIBCO Analytics Forum, especially our first keynote speaker, Nadi Bremer. Nadi's a visualization artist. She's an astronomer, a data scientist, a data viz specialist. She's created visual analytics and art for Google, Sony Music, UNICEF, New York Times, and recently published a best-selling book, Data Sketches, in 2021. Hey, Nadi, great to have you.
Hi, Michael. I'm really excited to be part of TAF 22.
Cool. Hey, can you show our listeners some of your favorite work real quick?
Yes, of course. It's all captured on my website, which you can see here. I have work, I have a blog, which I share all of the things that I think would be interesting for others. I have an art section, but in terms of my favorite work that I want to share, and I'll share more during our presentation at TAF, is this one that I did together with Sony Music, where I reimagined the golden record, but in terms of data. So if we had the streaming data from Spotify, from YouTube, and the actual playlists, the music itself in a way, and it's all sort of combined in this poster. And then I turned that into a system so it creates kind of like a musical, unique fingerprint for every song that they basically have data for.
That is super cool. So you can see that and a lot of Nadi's other projects, data viz, data art. We're even going to get into NFTs and all the rest. So looking forward to you folks joining Nadi and I for a keynote at TIBCO Analytics Forum 2022, June 13th to the 15th. Bye for now.